Welcome to codeLive. My name is Julián Duque. I'm a principal developer advocate here at Salesforce, and I'm super happy to stay with you today, sharing about my journey, my experience learning about Apex. This is the third part of the series, Apex for Node.js Developers. As you might know, I'm a Node.js developer, been working with Node.js since 2011, I guess. And lately, I've been learning Apex. For me, the best way to learn is to build something, to get a piece of code, and maybe do a refactor or to implement something specific. I'm not very good at following books or maybe following the documentation from A to Z or from scratch. I wanna have like an idea, something to build. So we've been building an application pretty much that connects to an external third-party API, the Open Weather API, and gets the weather for a specific location based on latitude and longitude. We show how to do that in Node.js by using an HTTP client, and then we also show how to do that in Apex by using the HTTP class. Then we, both in Node.js and in Apex, we created a REST service or an HTTP server to return that information or that weather information in JSON. In Node.js, we use Stochastify, and in Apex, we use the Apex REST services using the REST annotation. So you were able to get a class and expose certain methods using annotations. But there is one key aspect of web applications that we have not discussed yet, and it's data access. Normally, an application needs some sort of database so we can access data, and usually the CRUD methods, the create, read, update, and delete methods from a REST API maps to certain database operations, like reading, it is a select query, creating, it's an insert query, updating data, it is an update query, or deleting data, it is a delete query. So a REST API usually maps to a database. In Node.js, we have many options to perform these type of operations. I am going to be showing you today one of many. So there are like many ways a Node.js developer can solve this problem. I'm going to be showing you one way, and also how can we solve that same problem using Salesforce. Salesforce, I will say it's going to be optimized to solve this problem because Salesforce, it is kind of like a database on steroids. You can create data objects, and you have these super powerful data operations with Sql, and you have the DML from Apex, so you can perform these operations. So we are going to show you how to do that in Node.js using an ORM, which is an object relational mapping library, a library that maps database tables into programming languages objects. And we are going to implement certain API endpoints in Node. Then I will show you how to do that in Salesforce so we can have the parallel. Okay, that sounds good. If you have any questions, please let me know in the chat. And while we start, let me know where are you connecting from. I'm right now in the beautiful city of Tampa in Florida. It's a very nice weather here. It's warm. We can ask the API later how warm it is in Florida right now. But let me know in the chat where are you connecting from, and maybe we can use those cities for the application we are going to implement. Awesome. So let's start here where the innovation begins. So I mentioned that we are going to be using an ORM, and this ORM, it's called Sqlize. So Sqlize is a library in Node.js that allows you to, using the same code, like object-oriented code, access different database engines. So in web development world, we have different database engines. Usually these libraries works with open source. For example, PostgreSQL, that you can access Postgres on Heroku. You have MySQL, MariaDB, which are other two very popular open source databases. You have SQLite. SQLite is a very lightweight C-based database that stores information on a file. You can also access SQL Server, etc. So pretty much the same source code is going to be used to access a different database. Usually, these databases or these SQL databases have a different dialect, a different set of idioms and keywords and data types, so you can access the data and perform the queries. It is the same SQL, it is the same query language to access the information, but there are like slight differences. A library like Sqlize pretty much abstract all of those idioms, and depending of the dialect you are using, depending of the engine you are using, it will generate the query for you. So we don't need to worry about the engine. If in the future we change SQLite, which is the one that we are going to be using today, for Postgres, because we are going to deploy to Heroku, for example, we don't need to change the source code. We are going to change only the configuration option. In Salesforce, you don't need to worry about that. Salesforce speaks only one SQL language, and the data is already there. There is no different engine that you are going to be using in Salesforce, so we don't need to worry about making these decisions. So here is one key difference between building database applications in something like Node.js or database applications in Salesforce. Salesforce is going to be an opinionated platform. It's going to solve that problem for you. Don't think about it. We are giving you a lot of tools and a great way of deal with data. When you are building web applications, for example, using Node.js, you will need to start thinking about the architecture, the type of database that you are going to access, what are you going to be your data needs. So that will require some time. For me, I decide that I'm going to be using Sqlize, and I decide that for local development, I will use SQLite 3. Okay, so the documentation is telling me to install two dependencies, Sqlize and SQLite 3. So Sqlize is going to be the library, and SQLite 3 is going to be the driver that accesses that database. So remember that we have a Node project. Let me open the Node project. We have a Node project. The Node project has the server in Fastify that returns the weather information, and this weather client access the API that is deployed on Salesforce. Right? That's the last thing we did on our previous session. So we are getting the weather information from Salesforce, and then we have a server that pretty much returns that weather information. So what we want is, in both Node.js and Salesforce, because I'm going to be showing you how to solve the problem in both platforms, is to have a table of cities. So we are going to have multiple cities, and each city is going to have the location in latitude and longitude. So we can easily ask, for example, the weather of a specific city. So we are going to query the city information, and then we are going to call the API, right? Yeah, that's pretty much what we are going to do. So in our Node project, we need to install those dependencies. So let me go to the chat to see where people is connecting from. San Jose, California, Buenos Aires, Argentina. Awesome. Welcome back, Merrick. Good to have you here. So Merrick was working on a Flutter application. He shared with me an architecture. He was doing like some great things with Heroku as well. And he's letting us know that the Flutter application will use Heroku Postgres. Nice. So Merrick, we need to talk. Let me know. We can talk on Twitter if you wanna maybe join me someday here live and share what you built, how you connected those two worlds, like the Node application and the Salesforce application, and with Flutter and all the great things you did. I think that's a very good use case, because what I'm doing here is very educational, but I love when you sit down and implement an application that is different using the concepts we are teaching you here. So thank you very much for that, Merrick. So let's continue. Let me install the dependencies. Go into the documentation, copy and paste this command. We are using npm to install both Sqlize and SQLite 3. Remember, Sqlize is going to be the ORM library, and SQLite 3 is going to be the driver to access SQLite in our file system. Then we can do this manually, create the files manually and perform all the configuration, or use something like the Sqlize CLI. So there is something called the Sqlize CLI. And it is a CLI tool that allows you to initialize a project with Sqlize and to auto-generate the models, auto-generate the seeders, and migrate the database. And we are going to see those concepts in a moment. Usually, this is something that it's popular with ORM frameworks, and it also applies in other languages. For example, if you are working with Rails, if you are working with Elixir, if you are working with Python, there are like different ORMs or libraries that access databases. Here we are using Sqlize, which is one of the popular libraries for the Node.js ecosystem. And how can we use this? Okay, it's telling us to install Sqlize CLI as a dev dependency. What is the difference between dependency and dev dependency? So let's take a look at the package JSON. A dependency is something that my application needs on production while the application is running. A dev dependency is something that my application needs while I am building the application. So I don't need the CLI when I deploy my app. So when I deploy my app, this dependency, it is not installed. Only the ones that my application depends on runtime, okay? Okay, so we have the Sqlize CLI, we have our Node.js project, and let's execute the Sqlize command with npx. npx is part of npm, allows you to execute commands that you have installed either remotely, that they are available remotely on the Node.js ecosystem. So it's going to fetch the command and run it like temporarily in your computer, or if you install that specific library in your project. Sqlize CLI is already in my project, so if I execute npx Sqlize, it's going to execute that CLI command that it's giving me here with the different command options. So what we want to do here is initialize Sqlize. We want to turn this project into a project that supports Sqlize. So npx Sqlize init, and it did something. It created a configuration file, it created a models folder, it created a migrations folder, and it created a seeders folder. What is this? So models are pretty much the classes that are going to map a table in my database. So the schema, the objects are going to be models. So I'm going to be modeling a table as an object. The migration is going to be the scripts to create and tear down the tables in my database. So when I am going to migrate my database or to install my database, I'm going to be running the migration. And the seeders are going to be the files that seed my database, that creates the initial values. In Salesforce, we have seen the Apex scripts. It could be some sort of migrations or seeders, because we can also like add information in there, but we have better ways to load the data. We have the import tree, for example. We can have the data in different JSON format, and we can import a lot of data that way as well. And our models, we can create our object with the metadata in Salesforce in the setup, and then we export that metadata into our project, and then we can import it. So it's something similar that we can find in our Salesforce projects. And we are going to create an object in Salesforce later. Okay, what we have here in the models folder is an index.js file that pretty much does a lot of work for us. We don't need to touch this file. The only file that we are going to be interested in is the configuration. So here in the configuration, we have a way to configure my database. So here you are going to see 3 different environments. Usually in web development, we have different environments. We have development. It's where I am sitting right now on my IDE while writing code. Test, when I am running test or the automated test on my application. And production is where my application is deployed. Obviously, I need my application to connect to a production database. So I can have different environments configured in Sqlize. So my application can access different pieces of data. And with Sqlize, we can have, for example, development using SQLite 3 as what we are going to be using today, and production Postgres in Heroku, for example. What I'm going to do is forget about it. I'm going to focus on development. And development is going to be SQLite. So the dialect is going to be SQLite, and the storage, it's going to live in the data folder, and the database is going to be called, let's call it dv.sqlite. Okay. It's SQLite or SQLite. I don't know. Either way, I guess you understand. My mind gets a little bit confused. Let's call it SQLite. Okay. So let's create a data folder. And that's it. Here in data folder, I will have a dv.sqlite file, but we don't have any model yet. We have not defined any model. So we need to define a model. And to define a model, we can do it manually by creating a file, or we can use the CLI. I'm going to follow the easy way. I'm going to follow the CLI. I'm going to use it to generate my file. And let's create a model for the city. So Sqlize have model generate. So it will generate a model and its migration. And the migration, remember, it's going to be the script to load my table into the database. So let's see, what do we need to generate a model? So I'm using help here. So it's telling me you can pass a name for your model. This is a string, it is required. And you need to pass a list of attributes that are required. Okay, so my name is going to be city. That's going to be my my table. Let's do it uppercase here. City, beautiful. And my attributes, we have a name for the city. This is going to be a string. We have a latitude. It's going to be double. And we have a longitude. It's going to be double, right? So we are generating a city with the attributes name, latitude, and longitude. I run the model, and we see here that a new model was created and a new migration was created. Awesome. There is a new model that we can find here. It's called city. Awesome. This is my city class. And there is a migration here. So the migration is going to create the table cities with the following types: ID, name, latitude, longitude, and two timestamp files of fields created at and updated at. And the model, it's pretty much creating the class, and it's associating my types, name, latitude, and longitude. Awesome. And models here dynamically is going to load that information. Okay. So we created the migration and the model. I'm going to delete these two fields. I don't need dates for my database. I just need an ID, a name, a latitude, and longitude. Beautiful. On my table. And the model has the fields I need. Okay. Perfect. Now, what I need to do is to create my database. I will need to migrate my database. So for that, I will need to run Sqlize dv migrate. This is going to create that SQLite file that lives on data. So now I have the database, and I will be able to do something like, okay, using Sqlite 3 command line, this is something that you can install, for example, from the Sqlite homepage. Using download, you can download the Sqlite CLI tool, or if you are using Mac, you can use Homebrew to install it. And then pass the file name, and here I will check my tables, and I have my cities table, and I can perform a query to my cities table, and I don't have any data. So I have a database running locally right now. Perfect. What I need is to add some seeds, some information. How can we create the seeds? So let's do with Sqlize. We should have a seed generate. Awesome. Seed generate. Show me the help. I can pass a name. Awesome. So let me pass a name. Let's generate cities, because that's what we want to do. Have a bunch of different cities. And now on my seeders folder, I should have a file that gives me an example of how to perform an insertion of cities. Okay? So let's do that. Away, query interface, right? I am performing a bulk insert, and I'm going to be adding multiple cities. Okay. Let's accept Sao Paulo with the latitude. Oh, Sao Paulo with the latitude and the longitude. Awesome. Another city that I saw in the chat was San Jose. Another city, Buenos Aires. So let's do Buenos Aires. Buenos Aires. Awesome. I am letting GitHub Copilot giving me the latitude and longitude because I am not going to be finding those online. I'm going to be adding my city, which is Tampa. And another city in the chat. Like, give me one more city so we have different cities here to show. I will wait until you give me one city in the chat to add to my database. So these seeds are very, very important when you want to have like initial data for your database. For example, if you have a database with types, with the specific data that needs to be there when the application is deployed, seeders are very useful for that matter. Istanbul, Turkey. Awesome. So the last one, and thank you, Merrick, is going to be Istanbul. Istanbul. And the latitude and longitude for Istanbul is that one. Okay. So this is to create a table. You can also perform a query to tear down a database. Let's say away query interface, bulk delete cities, and it will delete all of the data. Depending on how are you running the CLI, you can add data or remove data. This is utilities that the ORM is giving you. So how can we load that information? So let's check Sqlize again. I am just following the documentation or the help, because I don't remember these commands. We have seed all. So run every seeder. So let's run that command. I like it. npx Sqlize dv seed all. Run all the seeders. It is telling me that all the cities has been added. How can we confirm? By connecting to our database. It is in data dv, select all from cities, and there we go. We have Sao Paulo, San Jose, Buenos Aires, Tampa, and Istanbul. Awesome. That's the data we have in SQLite, and we will be able to access this data from Node. Let me quit here, SQLite. How can we do this? So, do you remember that we had a server, and the server has a way to define API endpoint? So let's create an API endpoint, and I'm going to disable Copilot here because I want to do it on my own. Copilot is helping me a lot. So I'm going to define a route, right, to list the cities. So I'm going to define a new route to list the cities. I need to query the cities. Okay, so what I can do is get the database instance. So const database require models. This is going to require that index.js file, right? And then I can get the results. It will give me some metadata, and I can perform a dv Sqlize query, select everything from cities, and then I will reply with those results. So here I am performing a raw query. I am directly accessing the database and performing an SQL query. And for those of you that are Apex developers, this is pretty much what we do, but directly in the language. So Apex already has idioms to access the data without using any specific method or any special library like the one we are using here. You saw that I needed to do a lot of steps to be able to access data. Apex is going to be pretty much data in Apex is first-class citizen. And we are going to be seeing the same experiment in Apex in a moment. And let me log the result of metadata using the logger here. Info metadata. What I'm getting here. Awesome. So this is querying the database and returning the information. Let me start the server. Okay, this is starting. And here I am going to be calling localhost 3000 cities. And we have the data. We have Sao Paulo, we have San Jose, we have Buenos Aires, we have Tampa, and we have Istanbul. Right? I can do a where statement. For example, where ID equals 1, and it will give me just Sao Paulo. So it is working as expected. I am able to perform queries on my database. But usually ORMs are not meant to be used like this, right? ORMs are meant to be used as the object performing the operation. So we can change this a little bit by getting the city. For example, getting the city from DV. So I'm getting the city here as a class, and I can change pretty much this results and do something like city find all. So find all, now it is a method that the ORM is giving me, so I don't need to type any query. So this is giving me programming language constructs instead of SQL constructs to be able to access data. So if I run this code, I should have the same results. Okay, no such column created at. Oh, I knew that deleting the timestamps was going to be a problem. There is a way. Let us fix that. Awesome, I like when I have problems. With Sqlize no timestamps. Is there a way to disable timestamps? Timestamps false. Awesome. So in the model, in the configuration, I can say timestamps false, and I will be able to refresh and getting data. Awesome. So usually by default, the ORM was expecting those columns I deleted initially. They created that and updated that to exist. Those are called timestamp, used normally by these libraries to control when an object has been created and when the object has been updated. Those exist in Salesforce as well, but I wanted to keep this example simple. And this is what I disabled those. We are going to see that same thing in Salesforce. So we were able to list this information on our server by using the city find all, and there is also the find by ID, and you pass an ID. Find by ID, it is not a function, so it is different. Let me see the documentation. Getting started. Model querying finders. Oh, find by PK, no ID. It's called PK, like primary key. Now it's different. Now it is giving me Sao Paulo. Awesome. So you have different finders or different methods to perform certain operations. Find one, or create. So it will pretty much create the queries for you, and you can have associations, etc. But in Apex, we are more used to write the SQL or the query directly in the language. So we saw how to do this in Node. Let us perform the same thing in Salesforce. So we have our Salesforce application. We have our Salesforce org. Let me open the org again. Force SFDX, force source open. So I'm going to be opening the org that I already have. Okay. Force source, force org open. Awesome. So I'm opening the org that I already have authenticated. And what we are going to do is create an object. So we need to create a new object. That object is going to be a custom object called cities. That custom object is going to have a name and a location, and that location is going to be latitude and longitude. So we are going to store the same information and see how can we retrieve that information using the REST API service that we were learning how to implement it. So in Salesforce, we have the object manager. So here we are using this way to create the objects. We can use either the schema builder if it is a more complex object or a set of objects, or we can just create a custom object from the menu. You can create a custom object from the interface or by uploading a spreadsheet. I am going to be using the interface. The custom object is going to be called city, and the plural is cities. The object name is going to be city. Awesome. The city name. Perfect. That's the label. And I'm going to be saving this object. So, Joaquin, it is possible to use store procedures with SQLite. That is a very good question that we can ask SQLite. I know you can have, I think you can. You can do it, but let me ask SQLite store procedures. I think it is possible. I have not used them, but yes, you can have built-in functions. But remember that SQLite is a very lightweight database and everything is stored on a file, so maybe a store procedure is going to be too heavy for the use case. I will use SQLite for development purposes, or I will use SQLite for mobile databases, for things that are very, very small and don't require like a lot of load. But now, yeah, I have that question. Yeah, it says that store procedures are not really needed for SQLite, but other people might have different opinions. So yeah, very good questions, Joaquin. Very good question. I am sad I don't have like the proper answer for that because I haven't worked with the store procedures on SQLite. Okay, let's continue. We are in Salesforce creating the object. We are already creating the city object, and I already have a name. Usually the fields that comes with an object are the name that's required. We have the created by, which is who created the object. We have the last modified by, who updated the object, and the owner, who is the owner of the object. But we are going to be creating a new field, and that field is going to be the location. So Salesforce has a very specific type called geolocation, and this geolocation type is composed, it is a composite type of latitude and longitude. So we are going to be using the geolocation field here. It's going to be called location, and I will use it in decimal because all of the different data types that I've been using has been in decimal, like as a double. And decimal places, let's say 4 or 5. We don't need too much accuracy here. And the location is always required to save the record. Let me enable this on all the different apps and profiles. Save the location in the layout. And boom, we have location as a custom field here on my city object. Then let's add cities. So we can add cities. Let me see if I can find it here. Oh no, I can quickly create a tab for my city, for my custom object. Let me create a tab. Let me find a beautiful icon. It's something that looks like a city, these buildings. Okay. Perfect. I am creating a tab. Always visible. So I can easily admin my city from the UI. Perfect. It's created. Awesome. So now I can go and search for my city. Oh, I need to refresh. Let me refresh. Now I have cities here. I have the cities. I don't have anything recently viewed. Let me update my table. I can create a new city. And this is show me all the creating a new view. This is already exists. Okay, let me create a new city. The city name, let me use from my seeders. I have the seeders here. Let's go with Istanbul. The latitude is this one. And the longitude is this one. As you see, the location is composite. So location, one field, it's composed by 2 different text fields. Now I saved Istanbul. Awesome. I can view all of the cities. Fantastic. And let me select the fields to display. I want to show the latitude and longitude as well. And let me add another one. The other one, let's use Tampa. And this is the location of Tampa. Okay. So I'm storing the same data in Salesforce. I can create a JSON file with all of this data, so I can import it using the tree import from the CLI in my project. I can use all of those things. But so far, what I wanted to do is have this information here in Salesforce so I can implement it on my application where I create a new API service, a REST service that is going to list the cities. So remember that we can do that on my Apex project. Let's create a new class. Create a Apex class. Is going to be called cities resource. Cities resource needs to be global. And it's going to be a REST resource with the URL mapping, cities. And I have a global, and this is giving me a list of cities. It needs to be a static, right? Let me see. Yeah, it needs to be a static. Awesome. So it is a static list cities. This is going to be a do get. And what I do here is pass the HTTP GET annotation. And I use the so-called features that Apex has to perform the query directly in the language. I don't need to install any library. I don't need to do anything else like we did on our Node.js application. I just retrieve the cities, and I'm using the underscore C because it's a custom object. So I'm retrieving the cities by performing the query. So I'm getting the name, and I'm getting the location. This is a location. C. How can I get the location as the two properties? Let me just only get the name, and then we can figure that out because I don't know how to do it. And if you know how to do it in the chat, let me know. What I want to do is also query for the composed location. I don't know how to do it, but we can figure that out. Let's ask Salesforce Apex query geolocation fields. Location-based so-called queries. Oh, nice. So we can get the location latitude S and location longitude S because it is a composite. It is a composite field. We need to query in like that. Awesome. So we have the name, we have the location, the latitude and longitude. Let me format the document a little bit. And let's deploy. SFDX for source push. Let's hope we don't have any compilation issues. Okay. We deployed, and remember we need to perform the HTTP operation to get the cities. And to perform that HTTP operation, we need to get the token. Force org display verbose. I'm getting a new token because that token expired. So I'm getting the session token. I'm exporting that token as a environment variable, and I perform the HTTP GET, passing the headers. Oh, I mess it up. Okay, perfect. So I can do it with the curl or using the HTTP. So let's do it with the curl, SF token, app enterprise, Apex REST, but we are going against cities. Cities is the one that we created. And with the new SF token, there we go. There we go. So we have Istanbul and we have Tampa, right? So we were able to pretty much do the same in Node.js by using an external library, by using an external database, create a custom object or create an object, which is the city object, with those two extra properties, the latitude and longitude, the store information there. And we did the same thing in Salesforce. After we created the objects, what we can do is something like force source pool to get the metadata or the objects that we created. So here what we are doing is in our project, we are downloading the source code of the city object pretty much. And here you can take a look on my custom objects. Now I have the open weather, which is the custom setting that we had to store the weather API, and the city object with the location field. So this is what it's considered the source code of my custom objects, or in Salesforce world, it's known as the custom metadata. Okay, we have some questions here. Can you use the built-in Sql plugin? I can use the built-in Sql plugin, of course. What is that about? So let me take this query and I will show you in Visual Studio Code. We have the Sql builder. So we can create a query in the Sql builder. So this is going to connect to my org. I can search for an object, CET, and it will show me the fields. Here I need the name, and the other ones were the latitude and the longitude. And I can also get the created date. Awesome. So I'm building a query, and then I can run the query and it will give me the information. Istanbul, Tampa, and the created date. So that was going to be wiser instead of me going on the documentation, trying to use the plugin. Kudos to you, Joaquin, for giving me that pro tip. But always good when in doubt going to the documentation. Thank you, Ashnis. We figured that out. Awesome. Joaquin, I mean, the plugin that's come bundled with Salesforce extension pack. Yes. Is this the one that we use, I guess? Or do you mean another one? Ragul, is there any way we can receive Kafka events in Salesforce directly? Receive Kafka events in Salesforce directly. That I don't know. I don't have an answer for that. I know we can produce events, but not sure how can we consume events. I have received that question, for example, with Salesforce Functions, and Salesforce Functions is not capable to receive Kafka events. You can do it with Heroku, for example. You can have an Heroku application. The Heroku application in Node, in Java, in whatever language, can listen for Kafka events, and then my trigger an API in Salesforce and send the payload to Salesforce. That's something that can be done. But directly listening for Kafka events in Salesforce, that I don't know, and I will need to ask, but I have not seen that use case. Okay, that's what I wanted to show you today. Thank you very much for joining me on this Apex for Node.js Developer session, where we saw data access, pretty much a comparison between data access in Node.js and data access in Apex. Stay tuned. I need to see if I will continue with this series. Let me know in the chat or in Twitter if you like it. If you want to see more of my journey learning Apex from the point of view of a Node.js developer, let me know what you want to see. Or I can also work on some other stuff that I have prepared for you, like the new GraphQL API that I'm very excited to also share with you all about the new GraphQL API and all the cool stuff that we are doing for you, my beloved developers. Thank you very much for joining me, and see you on the next one. Bye-bye.